So this is my other tube tester. Well, one of my other tube testers. I repaired this the other day. I replaced the cord on it because the original cord was perished. The internal conductor insulation was cracking, pretty badly perished, so I replaced this cord. And you think that's an easy job, but what's a real pain is this grommet, which you can't quite see. Let's show you the grommet I'm talking about. You see that now? Yeah, just about. This grommet is a real pain. It was so tight, and the rubber, the original wire that was in here, the original rubber was so perished and hard, I just couldn't get this grommet out. In the end, I cut the wire off from either side and then drilled out the old wire to be able to close the grommet so that I could get the grommet out and then replace the cord. So anyway, that was fun. So, can we see it all? Yeah, not quite. Move it over a touch. These are ex-military tube testers. It's the TV7 B/U tester, this one, and they're quite sought after as far as tube testers, and I was quite lucky to get this one for a reasonable price, so I'm quite happy about it. And the book of instructions, well, the book of data for setting up the tube tester for the various tubes. So let me grab these two tubes and we'll do a quick comparison. So what are we testing again? We're testing the 6SQ7. So let me look up the 6SQ7. 6SQ7, 3 parts. Okay, so SQ7, we need obviously 6.3 volt filament, which help if I plug it in. Okay, so 6.3 volts for the filament. The filament pins are H and Y. So filaments H and Y. Can you see? Yeah, pretty much. Alright, so H and Y, and the first selector is 2, 6, 0, 3, and 1. The bias should be 11, and shunt 0, and then range B to read. It says the minimum value should be 19. So let's put our tubes in, one at a time, and see what we get. Actually, let's try the other one first, because the other one, with the key missing or broken. So the key is actually level with that. So what I'm going to do is put a line on there showing where the key where the key locates. Let's double check that. I lost the key. Come back. Yeah, so the key is right there. So I've marked there where the key resides, or where it should reside. So we're now set up for the first test. So I'm going to use this tube in the octal socket, line it up properly where the key would be, like so. Let's double check the settings. So it's a 6SQ7, filament is 6.3, HY for the filament pins, 2 for the grid, 6 for the plate, 0 for the screen, 3 for the cathode, and 1 for the suppressor grid. Bias 11, shunt at 0, range B. Press 3 for the mutual conductance value, and it should be a minimum of 19, and that's a triode, should be the triode section. So it's a double diode and triode. Those are the 3 parts of the tube. So let's put some power on and give it a chance to warm up, which it's now heating. And we're looking for a minimum value of 19 for the triode. And we're reading 41. So that looks good. And swap that out for the other one. Which still has the key. And we're just checking the triode section of the tube. And it should be minimum 19 on the meter here. If you can see that meter here, you can just about see it. Alright, we're warming up. And let's see. And that's pretty much solid 39. It's not changing. It's a solid 39. Okay. So it looks like the triode part of the tube is the same as the other one. Alright, so let's try the first diode section of that tube. So H and Y are still the same for the filament pins. We need 0 for the grid, 5 for the plate, 0 for the screen, 3 for the cathode, and 6 for the suppressor. bias at 0, shunt at 14, and we're good to test. One thing I didn't do previously was do a line voltage test. It's already set anyway from the last time I used this. It just crept up a little bit, but that's not going to be an issue that we didn't check that for the previous test, because they were reading the same and they were reading over the minimum value anyway. So line voltage test is spot on. Alright, so we've warmed the tube up a little and we've got everything set. We need to press button 2, which is the diode test. That's pretty low and falling. Yeah, that doesn't look very healthy at all. Okay, so maybe that one half of the actually, let's check the other half while we're at it. So the other half should be 0, 4, 0, 3, 6, bias 0, shunt 14, range. Oh, we weren't on the right range. Oh no, we went to the right range. Should have been on. Yeah, I was on B for the first part. Okay, so let's go back and check that again. 0, 4, 0, 3, 6, bias 0, shunt 14, range A, press 2. I think I was on the wrong range setting for the measurement. It's just going to be the sensitivity of the meter for the various shunt ranges. And press button 2. So we're looking for a minimum of 20. Oh well, that's going up to 60. 62. No, 64 on the meter. 64 on that diode. Now let's go back and check the first diode, because I didn't have the shunt set right. So first diode, same filament pins, that's not going to change. So here we need 0, 5, 0, 3, 6, 0 bias, 14 for the shunt, range A, and again press 2. So let's see what happens this time. And again, we're looking for a minimum value of 20. So press button 2. Yeah, that's failing. It's hardly, yeah, it's only just over a 10. So that diode, that other part of the diode is no good. The other section of the tube is no good. Alright, so we pretty much confirmed that this is no good. We'll now switch we'll now switch this tube for the one that we pretty sure is a good tube, where the key is broken, but we know where it's got to go, right there. So let's put that back on. We can do all three tests on this, but first test as a comparison to this one that we just took out, the faulty one. Let's see how well it performs. And press button 2. Yeah, that's much better. It's almost reading 50. That's right now it's 40, reading just a shade over 46. So that's working well. That's the one diode part of the tube. So let's check the other diode. So this one's the first, so this is got to be 4036, bias 0, shunt 14, range A, press 2. Okay. And yeah, again, functioning well. It's actually reading 50, almost 56. Minimum is 20, so we're good on that. Alright, so the last part is the triode section, and obviously the filament voltage stays the same. H and Y for the pins for the filament stay the same, and we need 6 0 3 1. No, I read that wrong. We want 2 6 2 6 0 3 1, and range B, shunt 0, bias at 11. Okay, let's double check. HY 6.3, HY 2 6 0 3 1, bias 11, shunt at 0, range B, and we press this time button 3 for the mutual conductance. Mutual conductance value. We're looking for a minimum of 19. And it's already 45. Yeah, it's 45. So that's a good one. And I'm going to switch that out for the other one, because I'm pretty sure it was good on the on that part of the tube, but I'm just curious what it actually reads. How it compares to the last one. Okay, so press button 3, looking for a minimum of 19. and it's 40. Yeah, so that's good. Yeah, but unfortunately the one diode in this tube is shot, so we are going to have to find a replacement for the 6SQ7, but only one of them, fortunately. So that's a bad tube. Okay, so that's about all I can do right now. I think we've proven that that tube is bad, and we've checked it on 2 different tube testers, and they both agree that this tube, the one part of the diode, or the one section of the diodes, is faulty. So that baby's got to be replaced, and this one I need to just glue the key back in place, and that will be good to go. So I'm going to finish this video at this point. Hope you liked the video. We haven't finished the servicing and repair and restoration of this radio, but we'll leave it there for now because it's getting a long video. So anyway, thanks for watching. If you enjoyed the video, give me a thumbs up and subscribe and hit that bell for more videos. Thanks. Bye for now.